This video is the user guide for the DAQ card. First step is to check if the product packaging is intact. Then check these items inside the package. First is the packing list. Then our specification document, communication protocol. Next is the 12-volt power adapter, followed by the power converter cable, Ethernet cable certification, RF cable. Finally, the capture card unit itself. The capture card unit has a product label. Compare it with your purchase model. To verify consistency, check for any visible defects on the capture card. Finally, give it a gentle shake to check for issues. Device connection. Let's first examine what each interface on the capture card is. The fiber port and Ethernet port versions have different interfaces. As you can see here, ensure you select the optical port version before purchasing, or the Ethernet port version. If the selection is incorrect, it must be returned to the factory for replacement. Now demonstrating fiber port version connection, the following components are required. First, 2 SFP Plus optical modules. They need to be identical, and this LC fiber optic patch cord, and our 10 gigabit Ethernet optical port network card. If you don't have one, you can choose to implement this by using a switch for relaying. There are 2 connection methods. One method involves connecting the capture card directly to the host computer via an optical port. The other is having the capture card relay through a switch to connect with the host. Since I'm using a laptop, which only has gigabit Ethernet port, I'll demonstrate using switch relay method. This limits my device speed to the gigabit Ethernet port rate if both the switch and host have 10G Ethernet ports. Using fiber optic relays can also achieve practical speeds. Now connecting the devices. First, ensure all devices are powered off. Then the second step, insert the optical module into this fiber port. Then connect our fiber cable. TXGR, RX, GTX. The Ethernet cable is already connected here. Finally, power on the devices. Thus, our actual fiber port version capture card connection is also completed. Now connecting the Ethernet port version capture card. First, connect this Ethernet port. Then, connect this side to the recorder. Then, power on the capture card. Ethernet port version capture card connection completed. Step 3. Device communication test. Our gigabit Ethernet and 10G fiber port tests follow the same method. First, check if device connections are secure. Then configure the IP address. Because our capture card uses UDP transmission protocol, so we need to set the IP address to the same subnet as the capture card. Change adapter settings for Ethernet. Set our IPv4 address to 192.1, 68.1, 37.3. Then we open the CMD console to perform ping communication test on the capture card. The capture card IP address is 192.1, 68.1, 37.2. Here shows both sending and receiving are okay. No packet loss. Means communication succeeded. If it shows request timed out or host unreachable, then confirm the following points. Is the capture card powered properly? Are all devices connected correctly? Or if SFP plus network card, etc., is not properly selected. It might also be our IP address wasn't configured correctly. Step 4. Data saving. In the delivery materials, we created a demo software. Specifically for this DAS system, the data collected by DAS can be saved. Then this data can be parsed using our proprietary process. And read, this data is the saved data. The exported data is in a variable format file. But if you need to save raw data, you'll need to follow the communication protocol in our SDK documentation. To program custom code for saving, we provide the UDP packet format here, including all data types, configuration, and content details. For further development, you should refer to our SDK documentation. To proceed with development, our SDK documentation